Continue with reading Rachel Carson's The Sea Around Us. And this is what summer feels like. It's July, it's a little warm, so I'm sitting in the shade, very comfortable here by the water feature. So we would expect when the seasons change. I've got a cherry tree up above me. The cherries ripen and fall in the summertime. In the fall, the leaves will change. But what if instead of living on land, what if we lived in the sea? What would the change of season look like? And that is what this chapter is all about. This chapter is called The Changing Year. All right? Okay, so here we go. The Changing Year, from The Sea Around Us by Rachel Carson. For the sea as a whole, the alternation of day and night, the passage of the seasons, the procession of the years, are lost in its vastness, obliterated in its own changeless eternity. But the surface waters are different. The face of the sea is always changing, crossed by colors, lights, and moving shadows. Sparkling in the sun, mysterious in the twilight, its aspects and its moods vary hour by hour. The surface waters move with the tides, stir to the breath of the winds, and rise and fall to the endless, hurrying forms of the waves. Most of all, they change with the advance of the seasons. Spring moves over the temperate lands of our northern hemisphere in a tide of new life, of pushing green shoots and unfolding buds, all its mysteries and meanings symbolized in the northward migration of the birds, the awakening of sluggish amphibian life as the chorus of frogs rises again from the wetlands. The different sound of the wind stirs the young leaves, where a month ago it rattled the bare branches. These things we associate with the land, and it's easy to suppose that at sea there could be no such feeling of advancing spring, but the signs are there. And seen with an understanding eye, they bring the same magical sense of awakening. In the sea, as on land, the spring is a time for the renewal of life. During the long months of winter in the temperate zones, the surface waters have been absorbing the cold. Now, the heavy water begins to sink, slipping down and displacing the warmer layers below. Rich stores of minerals have been accumulating on the floor of the continental shelf. Some freighted down the rivers from the lands, and some derived from sea creatures that have died and whose remains have drifted down to the bottom. Some from the shells that once encased a diatom, the streaming protoplasm of a radiolarian, or the transparent tissues of a pteropod. Nothing is wasted in the sea. Every particle of material is used over and over again. First by one creature, then by another. And when in spring the waters are deeply stirred, the warm bottom water brings to the surface a rich supply of minerals, ready for use by new forms of life. Just as land plants depend on minerals in the soil for their growth, every marine plant, even the smallest, is dependent upon the nutrient salts or minerals in the sea water. Diatoms must have silica, the element of which their fragile shells are fashioned. For these and all other microplants, phosphorus is an indispensable mineral, and some of these elements are in short supply, and in winter may be reduced below the minimum necessary for growth. The diatom population must tide itself over this season as best as it can. It faces a stark problem of survival, with no opportunity to increase, a problem of keeping alive the spark of life by forming tough, protective spores against the stringency of winter, a matter of existing in a dormant state in which no demands shall be made on an environment that already, with holds all but the most meager necessities of life. So, the diatoms hold their place in the winter like seeds of wheat in a field under snow and ice, the seeds from which the spring growth will come. These then are the elements of the vernal blooming of the sea, the seeds of dormant plants, the fertilizing chemicals, the warmth of the spring sun. In a sudden awakening, incredible in its swiftness, the simplest plants of the sea begin to multiply. Their increase is of astronomical proportions. The spring sea belongs at first to the diatoms and to all other microscopic plant life of the plankton. In the fierce intensity of their growth, they cover vast areas of ocean with a living blanket of their cells. Mile after mile of water may appear red or brown or green, the whole surface taking on the color of the infinitesimal grains of pigment contained in each of the plant cells. And I want to point out to you that over on the water feature, you can see that even on the surface of this small body of water, there is lots of algae. The plants have undisputed sway in the sea for only a short time. Almost at once, their own burst of multiplication is matched by a similar increase in the small animals of the plankton. It is the spawning time of the copepod and the glassworm, the pelagic shrimp and the winged snail. Hungry swarms of these little beasts of plankton roam through the waters, feeding on the abundant plants and themselves falling prey to larger creatures. Now in the spring, the surface waters become a vast nursery, from the hills and valleys of the continent's edge, lying far below, and from scattered shoals and banks. The eggs, or young, of many of the bottom animals rise to the surface of the sea, even those which, in their maturity, will sink down to a sedentary life on the bottom. That's the muck that you step in when you go into a pond. Spend the first weeks of life as freely swimming hunters of the plankton. So, as spring progresses, new batches of larvae rise into the surface each day. The young of fishes and crabs and mussels and tube worms mingling for a time with the regular members of the plankton. Under the steady and voracious grazing, the grasslands of the surface are soon depleted. The diatoms become more and more scarce, and with them, the other simple plants. Still, there are brief explosions of one or another form, when in a sudden orgy of cell division, it comes to claim whole areas of the sea for its own. So, for a time, each spring, the waters may become blotched with brown, jelly-like masses, and the fishermen's nets come up dripping a brown slime containing no fish. For the herring have turned away from these waters as though in loathing of the viscid, foul-smelling algae. But in less time than passes between the full moon and the new, the spring flowering of the Phaeocystus is past and the waters have cleared again. In the spring, the sea is filled with migrating fishes, some of them bound for the mouths of great rivers, which they will ascend to deposit their spawn. Such are the spring-run Chinooks, coming in from the deep Pacific feeding grounds to breast the rolling flood of the Columbia, the shad moving into the Chesapeake and the Hudson and the Connecticut, the alewives seeking 100 coastal streams of New England, the salmon feeling their way to the Penobscot and the Kennebec. For months or years, these fish have known only the vast spaces of the ocean. Now, the spring sea and the maturing of their own bodies lead them back to the rivers of their birth. With the subsiding of the diatoms and the completed spawning of many of the plankton animals and most of the fish, life in the surface waters slackens to the slower pace of midsummer, like we are right now in Ohio. Along the meeting places of the currents, the pale moon jelly Aurelia gathers in thousands, forming sinuous lines or windrows across miles of the sea. And the birds see their pale forms shimmering deep down in the green water. By midsummer, the large red jellyfish may have grown from the size of a thimble to that of an umbrella. The great jellyfish moves through the sea with rhythmic pulsations, trailing long tentacles, and as likely as not shepherding a little group of young cod or haddock, which find shelter under its bell and travel with it. Out over the plankton meadows of the North Atlantic, the dry twitter of the phalarope's small brown birds, wheeling and turning, dipping and rising, is heard for the first time since early spring. The phalaropes have nested on the Arctic tundras, reared their young, and now the first of them are returning to the sea. Most of them will continue south over the open water far from land, crossing the equator to the South Atlantic. Here they will follow where the great whales lead, for where the whales are, there also are swarms of plankton on which these strange little birds will grow fat. Now, autumn comes to the sea with a fresh blaze of phosphorescence, when every wave crest is aflame. Here and there, the whole surface may grow with sheets of cold fire, while below schools of fish pour the water like molten metal. Often the autumnal phosphorescence is caused by a fall flowering of the dinoflagellates, multiplying furiously in short-lived repetition of their vernal blooming. Sometimes the meaning of the glowing water is ominous. Off the Pacific coast of North America, it may mean that the sea is filled with a minute plant that contains a poison of strange and terrible virulence. About 4 days after it comes to dominate the coastal plankton, some of the fishes and shellfish in the vicinity become toxic. This is because in their normal feeding, they have strained the poisonous plankton out of the water. Mussels accumulate the toxins in their livers, and the toxins react on the human nervous system with an effect similar to that of strychnine. Because of these facts, it is generally understood along the Pacific coast that it is unwise to eat shellfish taken from coasts exposed to the open sea when this toxin may be abundant in summer or early fall. For generations before the white men came, the Indians knew this. As soon as the red streaks appeared in the sea and the waves began to flicker at night with the mysterious blue-green fires, the tribal leaders forbade the taking of mussels until these warning signals should have passed. They even set guards at intervals along the beaches to warn inlanders who might come down for shellfish and be unable to read the language of the sea. Excuse me. The surface waters now become the plaything of the winter gales. As the winds build up the giant storm waves and roar along their crests, lashing the water into foam and flying spray, it seems that life must forever have deserted this place. For the mood of the winter, we can read Joseph Conrad's description. The grayness of the whole immense surface, the wind furrows upon the faces of the waves, the great masses of foam, tossed about and waving like matted white locks, give to the sea a gale, an appearance of age, lusterless, dull, without gleams, as though it had been created before life itself. But the symbols of hope are not lacking, even in the grayness and bleakness of the winter sea. On land, we know that the apparent lifelessness of winter is an illusion. Look closely at the bare branches of a tree on which not the palest gleam of green can be discerned yet. Spaced along each branch are the leaf buds, all the spring's magic of swelling green concealed and safely preserved under the insulating overlapping layers. Pick off a piece of the rough bark of the trunk. There you will find hibernating insects. Dig down through the snow into the earth. There are the eggs of next summer's grasshoppers. There are the dormant seeds from which will come the grass, the herb, the oak tree. So too, the lifelessness, the hopelessness, the despair of a winter sea is an illusion. Everywhere are the assurances that the cycle has come to the full, containing the means of its own renewal. There is the promise of a new spring in the very iciness of the winter sea, in the chilling of the water, which must, before many weeks, become so heavy that it will plunge downward, precipitating the overturn that is the first act in the drama of spring. Already from the gray shapes of cod that have moved unseen by man through the cold sea to the spawning places, the glassy globules of eggs are rising into the surface waters, even in the harsh world of winter sea. These eggs will begin the swift divisions by which a granule of protoplasm becomes a living fishlet. Most of all, perhaps, there is assurance in the fine dust of life that remains in the surface waters, the invisible spores of the diatoms, needing only the touch of warming sun and fertilizing chemicals to repeat the magic of spring.